Okay, now that we have we've done some calculations, we know how to calculate the moment generating function. Let's understand why the moment generating function is important. One reason we've already seen is that the moment generating function allows us to compute the moments directly from the function, all of the moments in some sense all at once. And now what we want to talk about is what's called the uniqueness theorem for moment generating functions. Okay, so hey, it's going. All right, so if x and y are random variables with respective moment generating functions mx, my, such that there exists an epsilon bigger than or equal to 0, such that both mx and my are finite for all t less than or equal to epsilon, and mx equals my, then x is equal in distribution to y. So in general, this is hard to prove, so I'm not going to prove it, but it's something that we are going to make use of. And in the case of a discrete random variable, we can prove it. We could prove it more or less. And let me just write that down. We can show in the special case when x, y are non-negative integer values. And in this case, it relates us to the probability generating function. So we'll come back next and we will talk about the connection between the moment generating function and the probability generating function. And from there, it'll be more or less obvious that it has to be the case that if two non-negative integer valued random variables have equal moment generating functions, then they are in fact the same a copy of the same random variable. So we'll talk about that next time.